All right, now we're working on section 7.7, more radical equations. All right, let's see how this works. All right, so this is reviewing stuff we did last class. 3 root x equals 18. We isolate. So the first thing we're going to do is to divide by 3. That gives us root x equals 6. Now we have to square both sides. So x is equal to 6 squared, which makes x equal to 36. On the second one here, we need to set them both to have the same base, which is 3. 81 is 3. Well, okay, let me show you one other thing first real quick. Okay. 81 is 9 squared. 9 is 3 squared. So this gives me 3 to the 2 times 2 is 4. So now I have 3 to the x equals 3 to the 4. So I can set the exponents equal, which means x is 4. All right, and now we have the simplify. So we're going to multiply the two exponents because it's a power raised to a power. So when I multiply these two, I get 1. 2/3 times 3 halves gives me 6 over 6. X to the 1 is, of course, x. So that is my fully simplified. You can't really simplify it much more than that. All right. If the variable occurs within different radicands, okay, so isolate the more complicated radicand and square both sides. This is more complicated radical, sorry. And square both sides. And you have to be really careful because this pretty much always will generate some extraneous solutions. So let's see what that means. Okay, so notice I have a root x and a root x plus 3. So I'm going to isolate the root x plus, 33, sorry. So I have to add the root x over here. So that's what I've done here. And notice it's no longer on the left side. All right, now I square both sides, giving me just a simple x plus 33 on the left. But now remember, we have to FOIL this. You can't do 3 squared and root x squared. You have to FOIL. You're going to get 3 terms. Okay, you're going to get 3 squared, which is 9, root x squared, which is x, and then twice the cross product, 2 times 3 times root x, 6 root x. Okay, that's the formula. All right. Now, I'm going to isolate this radical. Now I have to do it again. So to isolate the radical, subtract x's. If I subtract an x from both sides, these two x's go away. And then I'm going to subtract the 9. And I flip sides so that I can get the radical on the left-hand side. Okay, so what does that look like? So what I've done here, let me erase some of this so I can make it a little more obvious for you what's going on. It looks like a big jump to me. Okay, so what I've done is I subtract the 6 root x to get it on the other side, okay? And I'm going to subtract the 33 to get all the constants on the right-hand side. So that's how I got a negative 6 root x and a negative 24. So if I divide both sides by negative 6, I have root x equals 4. Okay? So if root x is 4, I square both sides and I get x is 16. I'm going to check that into the original equation. So I'm going to plug the 16 in for the x here. Root 16 plus 33 minus, and again, I'm going to substitute in the 16 there, minus the square root of 16. Well, 16 plus 33 is 49. Square root of 49 is 7. So I get 7. And then root 16 becomes 4. So 7 minus 4 is 3. And yes, that is exactly what my answer was. So I'm good. So that's a check. So that's my solution. All right, here we only have one radical. So we're going to isolate the radical. I do that by adding the 3 root x over here, and I move the x over here. Okay, so isolating the radical. Now to divide by 3 would cause me grief, right? I'd end up with 10/3 and a 1/3. Who wants fractions? So if I leave it where it is, I just square it. It works just the same. Okay, so now I've got a 9x. All right, so I'm going to subtract that 9x. That's where the negative 29x comes from. All right, and remember, when I square this, I FOIL, I get 3 terms every time. All right, so I got my 3 terms. I subtract the 9x. Now I factor. Factors of 100 that add to 29 is 25 and 4. Since it's a plus, they have the same sign. Since this is a negative, they're both negatives. All right, so x minus 25, x minus 4. So this gives me x is 25 or 4. So I check each of those. So if x equals 25, that's actually on the next slide. All right, so here are my options. X is 4 or 25. So I check x equals 25. I plug it into the original equation. I get 3 root 25, which of course we know is 5. 3 times 5 is 15. 10 minus 15 does not equal the 25. So that means that is not a solution. We'll check the 4. 4 equals, does it? 10 minus 3 root 4. 3 root 4 is 2. 3 times 2 is 6. 10 minus 6 is indeed 4. So x equals 4 is my final solution. Yay! All right, equations of the form x to the ab, a rational exponent, equal k are also radical equations. Can be solved by raising each side to the b over a. Notice it is the reciprocal of a over b. Not the inverse, the reciprocal. Okay. Now, as you notice here, I've got to the 2/5. So I'm going to raise both sides to the 5/2. Okay? Now that makes these go away because they multiply and become 1. So I have a plus 7. Now, the reason this has to be inside the absolute value sign is that I had a even radical. Okay, so this then I take this 2 in the denominator and turn it into a square root. Square root of 4 is 2. 2 to the 5th is 32. So I have a plus 7 equals 32. Now this gives me actually 2. Remember when you're solving absolute value, you have 2 solutions. So I have a plus 7 is equal to plus or minus 32. So if it's a plus 32, then a is 25. If it's a negative 32, then a is negative 39. All right, so now I have to check those answers. All right, so if I plug in a is equal to 25, 25 plus 7 to the 2/5. Well, 25 plus 7 is 32. To the 2/5. The 5th root of 32 is 2. So that gives me 2 squared, which is 4, which was my question, one of my solutions. All right, a equals negative 39. Well, negative 39 plus 7 is negative 32. The 5th root, see, now it's odd. The 5 is odd. So the fact that that's a negative isn't going to be a problem. It's only a problem if the indice is even. Okay, so I have negative 2 then squared is 4. That also was my correct answer. So that means that both 25 and negative 39 are solutions. Yay. Now, if a radical equation contains radicals with different indexes, a cube root and a square root, a fourth root and a fifth root, raise both sides of the equation to the power that will change the smaller power to 1. Can hardly read that 1 over there. 2. Apologies. Okay, so notice this is to the 0.25, which is 1/4. And this one is to the 0.5, which is 1/2. 1/2 is larger, so we're going to go for the 1/4 first. I raise it to the 4th power. That's going to eliminate this one, and I just get the 4x plus 5. Okay, when I raise 1/2 to the 4th, whoops, that's supposed to be a 2. I apologize. It didn't really look like a 2. All right, we'll try better. My hand hit there we go. 1/2 times 4 is 4 over 2, which gives me 2. Okay, so that's why this began. There we go. Okay, so now I have 3x plus 2 squared. All right, so to do that, I've got to do the FOIL. And again, I'm going to get 3 terms. 9x squared plus 12x plus 4. I'm going to subtract 4x. And I'm going to subtract the 5. 12 minus 4 is 8. 4 minus 5 is -1. Now I factor. Factors of 1 when combined with factors of 3 subtract to 8. Factors of 3. I'm sorry, factors of 9. All right, so 9 times 1. 9 minus 1 is 8. There we go. The larger has to be a plus. Oh, nope, I'm wrong. That's what I had on there was correct. All right. Because go away, you silly thing. Oh, it's because I did that. There we go. Apologies. I'm just learning the system. Okay. So, x plus 1, 9x minus 1. The reason that's the bigger one, right? Because it's 9x. That's 1x. So the 1x is a negative, the 9x is a positive because of the plus. All right, so that means I have x equals -1 and x equals 1/9. I have to check my answers. -1, if I plug in -1, there we go. I end up with -4 plus 5 is 1. And I end up with -3 plus 2, which is -1. Okay. Now, the problem is that means the square root, right? Because it's to the 1/2 power. So the square root of -1 is I. The square 1 to the 0.25, 1 to the 1/4 is still 1. 4th root of 1 is still 1. Those don't equal. All right. So, -1 is not a solution. 1/9. We plug in 1/9. Why is it 49/9? 4/9. This becomes 4/9. But I have to change the 5 to 9ths. 5 times 9 is 45. So I have 45/9. But boy, that doesn't look like a 45. Right? So 4/9 and 45/9 is 49/9. 3/9, and this becomes 18/9. 3 and 18 is 21/9. They both have 3 that simplifies down to 7/3. Okay, the 4th root of 49 over 9, square root of, okay, so what this is 7/3 squared, right? Because the square root of 49 is 7 and the square root of 9 is 3. So what I did is change this into squares, and then when I multiply it times the 1/4, now I've got 2 times 1/4, which is 1/2, and I've got 7/3 to the 1/2. Alrighty. So those did equal, so 1/9 is my only solution. All right, and there's your homework.